Hello, everyone. So, hi, Yarek, and hello. So this is meant to be an interactive session and answer questions as much as possible, and not just, a presentation when we show a lot of things. So feel free to interrupt, ask questions, that reasonably, right? Like it needs to stay on topic, but feel free to interrupt and ask questions. Hi, so I'll start. So this is I'm Julien. I'm the lead for the OpenLineage project, and Maciej is here with me, and is also one of the key contributors to the project. And so today we'll talk about specifically how OpenLineage works with Airflow and the benefits of the IP53 of moving the integration as a more native Airflow one. So we prepared a bit of an agenda, and thank you, Yarek, for giving a lot of feedback of what would be good topics. So I'll start with a quick intro on the OpenLineage goals, but it's just like a quick reminder. I'll go fast, and then Maciej will talk about the existing lineage support in Airflow and what existed before this. And we talk about specifically the OpenLineage design and how we make things more extensible and so on. And then Maciej will dive in the OpenLineage in Airflow, how the integration worked before IP53, how it's going to be changing and easier to maintain afterwards, and so on. So first, on the OpenLineage goals. So quickly, one key aspect of this is, there's lots of discussion on how lineage work, how you solve lineage, and one of the observation here is that lineage is something you want to capture as the transformation is running, what's happening, and what the transformation is reading from, where it's writing to, and how everything connects together. And that, whether independently of what transformation layer you're using, whether it's a data warehouse, SQL, Spark, DBT, ETL tools, BI tools, all of those things, we have transformation and want to observe what's happening, and so integrate with data orchestration system and know how things are happening. And so collect all this information as things are running. And so hence how we wrote the mission for OpenLineage is to define an open sender for the collection of lineage metadata from pipelines as they are running, right? And so it's, in its sense, it's very similar to OpenTelemetry, or as part of OpenTelemetry, when you capture traces as services are operating in OpenLineage, you capture lineage as transformations are running. And one of the key aspects of getting these projects is before every data system, every collector of metadata, to build a repository of all the things that exist, would have to integrate with all the things and reverse engineer how everything is working and figure out the lineage or use various APIs if they exist. And that creates a lot of duplication. It's very brittle because it's a moving target. And so the discussion is, if we get all together and we define one standard to expose lineage, it removes a lot of duplication, it simplifies the conversation, there's a lot less wasted effort, and it's a lot more reliable because it's a spec that everything goes against, and that's more stable. And so on that, I'll pass to Maciej to talk about the existing lineage in Airflow.
Should I share screen myself?
Yeah, let me release the screen. Here you go.
Okay. So how does the lineage setup in Airflow works right now? So it relies on manual annotation. Operators accept special values called inlets and outlets that basically tell what are the tasks that the task consumes and produces. So they have to be defined manually in a DAG file as top-level code, and inlets can be specified as auto, so they will like automatically pick up preceding tasks out as inlets. And we can see here that basically you have to define file, pass it to the empty operator. Then you have to like define multiple files, pass it to bash operator, and in the end, we see all this code that has to be added to the DAG file that basically pick it up. So what are the entities that we are like passing to these operators? Basically, there are any others annotated classes, and Airflow defines some base entities like user, table, file, URL, I think. And users can also define their own or use some vendor provided ones. Then the lineage collected goes to lineage backend. Its task is to pass and transform the collected lineage to some kind of particular system. And there are no lineage backends defined in Airflow itself. However, they are basically vendor provided. So there is like Data Hub lineage backend, Atlan lineage backend. They also provide their own entities to use as inlets or outlets. And what are the challenges with this system? What we think can improve? So first, we have to manually annotate the DAG, right? We can see this is the example from the docs of lineage. So it's not very representative, but we can see like 12 of these 30 lines is just manual annotation, and some like inline parts are also used. So in the end, slightly more. But this is something that some people have to do with, I don't know, hundreds or thousands of DAGs. So there's a lot of work. There's a lot of overhead just to have lineage. Second part is that there are like different entities between integrations. Airflow defines just a few entity types. And I looked at some of the lineage backend implementations, and they all use like their own defined entity types. So this causes fragmentation of the model. There's no single like description of dataset that you can use. You have to learn the one that, for example, Data Hub provides, use it everywhere. And it means that changing lineage system is hard. You not only need to learn what other system does and switch the lineage backend to it, you might have to rewrite all of your DAGs. So, this is also not helping with like customized metadata, like dataset tags. And dependency on manual lineage has another consequence. So there's a way more surface for bugs and entities that doesn't match, because the same person can name the same data set in a different way. Or, if you have 100 DAGs that are just looking at what data set, there's a big chance that somebody will misspell it and they won't match. And your lineage backend will think they are possibly the different entities. And something that maybe, hurts only us, but it's that the notification was only on success. And Marquez, which is like reference implementation of OpenLineage backend, can utilize more information when the task started, when it failed, to provide additional value, like trace task that failed to some failure earlier in a chain. So back to Julien.
Before I start, are there any questions? Okay. So I'll get back to my slides. One second. So, and one thing to note as well is when we we had started opening issues in the Airflow community for discussing adding the failure scenarios to lineage backend and some other things. And the recommendation was to start the new listener, task list instance listener. That is now the way that we plug in OpenLineage plugs in into Airflow. So quick view on the OpenLineage design. So OpenLineage is meant to be a spec, and there's a data model, and the core data model is very simple. It identifies 3 entities. So there's this notion of job, which is in the Airflow context, it can be the DAG itself or the tasks. And it's a context of something that is recurrent, that runs more than once, that may be running every day, every hour, or some other frequency, or maybe it's triggered, but it's not on a fixed frequency, but it's a unique identifier for the thing that is running. So in the Airflow world, the identifier is built for a task, for example, is dagname.taskname. The run then is the entity that is an actual instance of the job running. So for Airflow, it's a task instance, for example. There's a unique ID, and it's going to have a start and an end and metadata attached to it. And then data sets are for modeling the inputs and outputs, right? So you will have a job that runs multiple times and as data sets as inputs and outputs. So that's a core model of Lineage that's very simple. And the core thing it's doing is creating consistent names for data set. There's a spec that defines how you name a data set in a unique way, unique canonical way, so that multiple things that are reading or writing to a data set will connect in the lineage graph. And each of those entities, you can define facets. So a facet is a piece of metadata with its own schema that helps describing an aspect of an entity. And sorry, I have my example. Yeah. So, and I'll get back to this in the next slide. So lineage is reported as a series of the synchronous run event. Typically, you will have a start event at the beginning when the task starts. And it will contain information that what's the version of the source code, what are the run parameters, some information, and you'll have a complete event sent at the end. You'll also send optionally other events in the middle if there are salient information you want to pass. So it captures the life cycle of the run with the relative metadata. And so typically you have start and then complete, so it fails, or maybe it's been aborted, is the typical life cycle. And so the notion of facet is really the thing that enables specializing each of those entities, right? They're self-documented. They have a JSON schema for each of them. They have a self-descriptive names. They're flexible, and it's scalable on enabling extending the spec in the future. So some examples on the dataset, for example, you might capture data quality metrics or statistics, like, for example, how many rows were written by this run in this dataset. You can capture the schema, what is the schema of this dataset, and that can be different depending on whether it's a table in a warehouse or if it's a file in a bucket. I may capture version. If, let's say, you're using Iceberg or something similar, you can capture the actual version you were consuming or producing. On the job, you might have the version of the source code. You might have the dependencies. You could capture the query plan. On the run, you can have like a query profile, for example, and how much, for example, you could capture how many cluster milliseconds did this particular query reuse and have a proxy for how much it might cost. So this is the kind of information that can be described as facet, and it's each atomic piece of metadata. And makes it very easy to extend the model because you can just add a new facet, and it enables very focused conversations, while we have people focusing on data quality. They can discuss the data quality facets. You have people focused on governance. They can discuss the column lineage facet. And it enables moving the spec without a big monolithic spec that takes a long time to agree on and build consensus, right? We can focus on small specs and move the spec faster and make it a bit more decentralized. There's this notion of custom facet. When someone can create their own facet, even if it's not in the spec, all you need to do is publish JSON schema on the URL so that people can use it. And that enables experimenting with a spec without being dependent on the central project for approval or anything. And then that enables those facets can be promoted later to be part of the core spec if there's more wide usage. And if there are no questions, I'll pass it on to Maciej to go in the details of this integration.
Jarek has a question.
Yes, I have a question.
Go ahead.
So thank you for this so far. The question I have, the facets, how discoverable they are, or kind of how common they are in terms of the standardization between the different tools that are going to use it. Are there any kind of definitions that are predefined in standards? And also very connected, how can you map the entities that you've shown before from our Airflow, like user, file, etc.? Do they have corresponding facets already? How does it look like?
So the core facet, you'll find them on the OpenLineage GitHub, right? There's you have a folder, and there's a spec folder. You have a facets folder with all the JSON schemas of all the spec of the facet. You can discover them there. For custom facets, right now we've been recommending people to commit the schema with the project that defined them. So usually you can find them on the project that defined them. We have not created a registry for custom facet yet. So if you're a data catalog, right, and you receive OpenLineage data and it uses custom facet, the custom facet have to put their URL as the identifier of the schema in the facet itself. That's a recommended. That's the way JSON schema, you define where's the schema, so you can find them this way. We've been discussing adding a registry on the OpenLineage side so people can declare there when they define custom facet and point to their repository so they're easier to discover. So that was the first part of your question. And what was the second part of your question? Sorry, yeah.
The standard, the entities that current
open. Oh yeah, the entities.
Yes.
Yes. Part of this, I think there's probably an opportunity to add a couple of facets in OpenLineage as part of this to make sure there's one-to-one mapping. We do have mapping where, when it's a table, typically of the schema that goes with it are a certain number of facets that are specific to tables. When it's a file, what's in the spec that maps them is the naming convention on how you build the URLs for the unique name for the data set. So all of them will be mapped. Definitely database, the table, file, so on. They have a corresponding in the naming spec ways to uniquely identify them using a defined spec. And I think as part of the IP53, we make sure it's all one-to-one and they all map, right?
Yeah, because this is one of the kind of worries I have and things that I want to make sure that is addressed is there is an easy way how to go from image to the new one, and seems like if somebody would like to use them, the old one already use the old ones, and even like custom ones, because probably people develop their own custom entities, inlets, outlets, having for them even not even mapping everything, but having a clear way how they can do that, it would be helpful.
Yeah. So there's definitely a spec on the OpenLineage side that define all the types of entities and how you map them. So we make sure this is really clear as part of this. Okay. So I'll leave the screen back to Maciej.
Yeah, and I'll be talking a bit about this later, but if it would be great if we had the information somehow later what people use, and because we can't have facets for information that we don't know about, right? That somebody collects.
I think this is like fully distributed right now. Hard to say who uses
Yeah,
what.
sure. So it would be, we're not planning to, push something and then leave to greater fields, but working with community to expand this coverage. But yeah, so we have talked about OpenLineage and Airflow, but we haven't talked about why do we want OpenLineage in Airflow. So right now we have an integration that is an external plugin that works basically like this. We defined extractors, which is a special class that created for supported operators that understands their internals, what methods they have, what data they have, and know what to look at for what we need for Lineage. And this isn't the great solution. It depends on the internals of the operator. It's brittle, and it creates more work for us to keep up with the changes, to maintain compatibility, because we have one integration and there are multiple provider versions with multiple Airflow versions. So ideally, each operator would expose Lineage themselves, and we would have the Lineage contract. So besides that, we have common parts of our integration. We get called by Airflow by listener API, which I will talk briefly later about. We find the extractor that is responsible for extracting data from some operator. Then the whole integration enriches data returned from extractor with some common facets, like some run related data, stuff like proper start and end time, nominal start and end time. We also provide various utilities for extractors so that we don't have to repeat the code everywhere. We have a DAG monitoring, so additional mechanism that is using listener API to notify our backend when the DAG started and ended. And we have a backup mechanism for getting the lineage that was already defined manually. So this is basically something that we want to keep mostly in Airflow.
Question, if I might question on this.
Sure.
So, Julien, I guess in the past we talked about these extractors in the current OpenLineage architecture and the plans for it going forward. And in the past, I think you stated that in the new architecture, the separation between the lineage being emitted or present in operators and extractors, again, processing the same data in another place of code, that this will go away and the code will be more modular with the logic being in one place. Is it still the plan?
Yes, yes. I just haven't got to it yet.
Yeah, this is exactly what Maciej is talking about. So there's the before with the extractor, and he's going to show the after where it's easier to maintain.
So to visualize, that's exactly what you talk about, right? Now we have operators and we have separate structures that are responsible for this. And the extractors just look like this. So they have a base class, have to extend base class. They give us names of the supported operators, because sometimes the same extractor can be used for multiple operators. And then they have a method that they are getting called on init. The extractor is past the operator, so it can use the data defined on operator to define data sets, define custom facets. There is also one other method that I do not show, which is extract on complete. And this is basically what it says. It's called when the task is completed. So you can use everything that was set up by operator on execute method. So there are also custom extractors. People that's using OpenLineage integration can define them, but it's not everything. You have to also register it. So in addition to using those available extractors, if somebody writes their own operator and want to have the lineage from it, it has to define the variable right now. So this is also, not ideal because people love doing typos in this kind of things. And then things break then, right? Because first, Airflow does score changes. We don't have any contract between core Airflow and OpenLineage. So adding things like map tasks and async operators, is not handled when Airflow releases. We need to look at them, handle them explicitly, and the same, but in like much greater numbers, goes for operator changes. So there are backwards incompatible changes in operators, but again, there's no contract. So people change something like name of the method, look at Airflow code base, everything is changed, and it's good, right? It passed the tests, but then we have to do stuff like on the bottom. So this is not perfect, but again, we can't complain because there's no promise of like stability of some names and methods. So what we do want to fix it, we want to have operators responsible for each own lineage. And why? Because we don't have to expose internals, right? The data that is set up on operator will be internal to the operator, and any potentially breaking change, like renaming something, will be detected in tests that we have, and it can be fixed in the same PR. So if you like rename, as in this example, get DB hook to get hook, or in reverse, then you can change the lineage getting in the same place. So one fix for everything, and there's no registering cost because it's on the same class. So in this example, like I took BigQuery to GCS operator, and this is basically pretty much all the code with one exception. There are like multiple URIs that your BigQuery to GCS operator can copy data. I've just taken the first one for simplicity. And this defines input data set, which is BigQuery's table ID, output data set, which is Google Storage namespace. So, right, and this fixes all the problems that we had with original lineage in Airflow, so that it's not manual, it's automatic. Users don't have to do anything, basically. Instead of like diverging entity model, we have OpenLineage entity model that for same data set works the same each time. There's no like possibility for user to break the lineage because they don't define it, and it's not done for every DAG, it's done once for every operator in their code. So from like operator maintainer perspective, if you like define the operators and maintain them, if you want to have lineage, it's way simpler than extractor, right? Because what I said before, you don't have to like expose some data and have some undefined contract. You define methods in the same class with the rest of the code. The data is encapsulated, and right with this OpenLineage AP, you can use the utilities that can simplify getting to lineage. From example, if you use SQL, then we provide SQL parser for this. And also, like not everything has to have lineage. So there are hundreds of operators in Airflow. A lot of them process data, and it's useful to have lineage support, but there's like great number of them that won't be useful in this context. So I think I have the three great categories that won't ever have lineage. First are those like Slack API operator, Discord webhook operators, like there are Telegram, and I think some Chinese, I don't know, there are a few of them, right? These are just messaging services. They're useful for like alerting, or you want to like notify on Slack that your big DAG has finished processing, but I don't think that's metadata that we need in lineage context. Second are like DevOps ones. So you can create your compute engine instance, E3 instance, buckets. They are usually introducing metadata, right? But it's not exactly lineage. However, there are like operators like EMR create job operator, and they like both provide, both create EMR cluster, and they also submit a job to it. So in this case, I think this would provide useful lineage, right? And third category are those protocol operators like simple HTTP operator. And they can be used for some data stuff, but they are like way too generic to have something that would be useful in this context. So in this case, the users would have to do additional work to provide some interesting metadata, right? So if you have your operator, so how to get additional metadata, right? A lot of them is like got in the original operator, but it's not like saved. Basically, for example, for BigQuery, we can call BigQuery API to get like all the lineage because it provides the lineage and we can format it in OpenLineage format. But job ID is like received from hook, and then it's not like saved on the operator. So if we have like metadata that was exposed or information that can be used for lineage, we can set it on the operator and then later use it. So like a lot of it is simple changes like saving the configuration, saving the job ID, and making it accessible. And do not like process the data on the execute method because it's optional, right? Not if someone doesn't have configured OpenLineage or any lineage backend, they don't need this information. So do not do like network calls and processing to be done on execute method. It should be done when the lineage collection is called. So if you save the job ID, it's like free from operator perspective. And then like on complete method, we can call BigQuery and do all this processing that needs. And this will be called only if the lineage is configured. So another thing is like embedded tests make changes easy. So I said that, you know, let's have an operator that copies back data from one bucket to another, right? It's like kind of simple. Here we have input bucket, output bucket. We provide paths, and then on execute, some hook is called and the action is performed. And we have very simple method that basically creates data sets, returns them, and we have a test that confirms the data sets are well formatted, right? But somebody wants to like copy data from one bucket to multiple buckets. So you provide input bucket, output buckets and output paths instead of single bucket and path. And then, you know, if it works like this and this wouldn't be well tested, it would just fail on extractor. But right now, if you have tests, they fail, right? Because you used some, here you used output bucket and output path arguments that do not exist anymore. So the test failed, and we can fix the lineage extraction and fix the tests in the same PR that created it, and then the test passes and everyone is happy. Right. So from Airflow maintainer perspective, I think it's the shortest part of this presentation because most of what we already want is already in Airflow. This listener API that we'll talk in a moment. The second is that having OpenLineage in Airflow, we reduce back count that we have, and this later fixed because we can allow testing of lineage for those new features because before they are released. So the API that we use in OpenLineage, and that's already defined and tested and runs, is the listeners API that basically used plugin library to define hook specs, and then the plugin can define implementations of like any subset of those methods, and then we are like calling them in appropriate places in in the Airflow run lifecycle. And we have like lifecycle methods that are called like before the plugin is called in another way, on starting, before stopping. We can do stuff like starting the thread pool for scheduler, and we can do other initialization that we want. We have task instance methods that are called before and after task instance was running, and the same for DAG. So from Airflow perspective, Airflow maintainer perspective, we want them to work as they want right now. And in the both of those cases, having Lineage integrated, it results in way less bugs and way less work that we all have to do. I don't want to tell that there's no work to be done by any of those people, right? But it's a like common project that results in overall more work done and less time wasted on fixing bugs. So right, we support different consumers, and so if you implement OpenLineage, if you listen on like HTTP port, we have HTTP client that we are using to send the data for the same for like Kafka topic. And we do this by having a pluggable mechanism that is called listeners, not listeners, sorry, custom transport and transports. So they, if you want to, accept OpenLineage events, it's a best option to use that. And additionally, you would be able to accept events from like Spark, DBT. But if the mechanism for receiving this does not exist yet, because I don't know, you use gRPC, then you can define your custom transport, and it looks very similar to this Lineage backend. It's one method, it's a configuration, and you can define how to emit the data that you received, which is the full OpenLineage event with all the Airflow metadata added on top. And additionally, if you like, want to provide support for something that doesn't yet support OpenLineage, you can transform the data to your own custom format. But if you want to like provide gRPC support, it's also the way to do this. And like, what's the future, right? We talked about operators, but we also want to provide support for something like AAP41 datasets in the future, and for Python operator, because this is the most used operator in Airflow. It won't be covered, but what we talked about, which applies to Taskflow as well. But we think of adding similar mechanism for hooks that we talked. So if they could track their own lineage when called, and then Python operator at the end would collect it from hooks and present it as its own lineage by the mechanism that we propose. So, but this is, this is not something that we could do while we were outside of Airflow. So having a native OpenLineage integration makes this possible at all. And this is something we would also need help to figure out how to do this best in collaboration with Airflow community. So we are looking forward to it. And like at the end, OpenLineage is open standard. So everyone is welcome to contribute, influence its design, implementation, open issues, fix bugs. And we think that having native integration will make all of this Lineage work easier for everyone, not only us. And it will reduce the amount of operational maintenance bugs related to Lineage and like related to also other operator bugs and user bugs, because the Lineage information can help with that as it's runtime Lineage. So that's all from my side, and yeah, we would like to have questions.
Nice start. Question. So thank you for this presentation. So you showed at the very beginning the inlets and outlets in the old kind of interface. I just would like to understand what's the progression from the inlet outlets and the current the new mechanism. Like, is current OpenLineage integration, does it require you to put inlets and outlets, or does it automatically detects the lineage information which it sends, or like what's the relation between the inlets, outlets, and the current OpenLineage, current and future integration with the OpenLineage?
So current integration, basically, if you have inlets and outlets defined on an operator that we don't support, like empty operator, I think, which is, kind of useless, but we use it as a backup mechanism. So then we transform the data, I think, in some kind of custom facet way to our data sets, basically, which is not fully like naming compliant, but it's compliant to what it's already said here. But if we have extractor defined for the operator, then we use the extractor and skip the inlet and outlet information. And I think we would probably want to do it the same way. If the operator supports their own lineage, then we use it. If not, then the inlets and outlets are used, if set. However, this might be, a customizable option. And second, I think it would be great to provide greater visibility on what happens, right? How do we format this address entity to OpenLineage entity?
So that also relates to my previous question about like the standards defined for the facets defined maybe for corresponding to those, maybe that would be the solution. Because if we have, as I understand, if we have fast facets defined for exactly this kind of old entities of Airflow, the kind of the deprecated or kind of legacy versions, if we could have facets for that, we could convert those inlets and outlets into those facets, I believe.
So the problem with that is that we could, have a facet that dumps the entity inside and then send it somewhere. What we can't do, I think, is like having a custom, table Airflow facet, file Airflow facet, user Airflow facet, because from what I saw, I might be mistaken, but most of those are custom for like different backends.
Okay.
So we don't know what they are, right? There's no like standard. If we saw like data hub dataset facet, data hub dataset, we'd have to do some custom thing for it, right? And it's like defined outside of Airflow somewhere.
Maybe a way is to have someone provide not the extractor, but like converter of the inlets and outlets into the actual facets, a custom one.
Yeah, so this would be good opportunity to use like custom transport. If you want to use this to send data to like some other backend, you can, get the event, get those facets, and then convert them to what you want.
Okay.
And additionally, of course, this will support everything else that we done for OpenLineage. So if you had like custom DAG, you won't have to do this again for next DAG, right? Because it will use the automatic mechanism that was.
Yeah, but transport is for, as I understand, is for installation. Let's say you say, okay, this kind of OpenLineage is emitted via this kind of transport for all the DAGs in your system, basically. Yes, this is how transport works.
Yes. Yes, but the events will be different, right?
Yes, of course. Yes. Okay.
So this kind of translates to the question that I had. What's the point of configuration for OpenLineage here? Is the assumption that this is like a single tenant and the whole Airflow deployment sends data to the same meta storage, whatever it is, and whether or not it will be automatically enabled for everything that is deployed there? Like, what if the user wants to have the lineage enabled only for some sub team?
That's a great question because we don't do anything with it. So it's a great moment to discuss this and do what's best, I think. Right now.
So if in the context of a multi-tenant Airflow, then this configuration needs to be at the right level in that, like per tenant or something. But yeah, it is meant to be, where do we send the OpenLineage event, right? So it could be whatever metadata service you want to use.
And the multi-tenant is not yet defined in Airflow, like it's just in progress. So we can definitely define it at the moment where we will be defining the split of tenants in Airflow, because it's not this concept doesn't exist currently, but we plan to do that. So then we could define that it also covers the OpenLineage configuration, which might be different for different tenants, for example. That is entirely possible.
So I showed you the how we configured one thing with environment variable, but we want everything to be configurable with the Airflow standard configuration, right? So this is
actually this point when I'm thinking about that, this is yet another reason why having OpenLineage in Airflow makes sense, because then all this will evolve together. So like whenever we actually go to the moment where we can have multiple tenants and different access, like separation, isolation, then we will split everything that relates to it, including OpenLineage if it's there. If it's not, you would have to do it as an afterthought. Yeah. So
exactly.
Yeah.
And I'm not sure if we need to evolve some of those APIs, right? Like listener API.
Yeah, that's there. That's done. Yeah.
Right, but okay. So that's my question, I guess. How would this plugin know which tenant it is in
So I think that's where the multi-tenancy would abstract that out, right? Like you don't need to know. There's a plugin instance per tenant or something.
Yes, that's what we would prefer, right? Because if we could access another tenant, if it was done from outside, it wouldn't be very good multi-tenancy.
Eugene is raising his hands. Yeah. Go ahead. We can't hear you, Eugene.
Can you hear me now?
Yes.
Yes.
Oh, okay. So first of all, thank you very much for presentation. I have one question. Maciej, you were showing that every operator is supposed to generate lineage, and lineage has inlets and outlets. So basically, you define lineage between sources and targets. For example, like if you, so let me ask you this question. What do you think about the case when my operator will generate lineage between multiple sources and targets? For example, I transfer file 1 to file 2 and file 3 to file 4. So I need to have 2 inlets lists and 2 outlets lists, which are connected separately.
So this is interesting case, right? And I think we need to tackle this on like Python operator level, because then you can do anything you want, right? And right now the assumption is that we have one list and one list of inputs, one list of outputs, and then we figure out if we have column level information, which actually influences which. So right now, if you wouldn't have like column level info, which for files wouldn't make sense, right? You won't have that mapping.
But maybe maybe I'll add from my side how I understand it. So you can have multiple outlets right now. It's just a list of outlets, yes, or list of inlets.
Yeah. You can have multiple inputs and multiple outputs, but you can have list of lists, right? So if you have from A to B and from B to C, you'll have A and B in inputs and B and C in outputs.
But I think Eugene, and correct me, Eugene, if I'm right, but you were asking about exactly having just multiple outputs from not multiple lists of outputs, but multiple outputs simply.
Oh,
No,
then
no,
that's supported.
No, I'm actually asking what is Maciej is answering about. So I'm asking about the case when I want to build lineage between A and B. The edge will be from A to B, and second edge will be from C to D. I don't want to have edge from source 1 to target 2 and from source 2 to target 1. So I don't want to be misrepresented my lineage. Do you see what I mean?
Yeah, I think that's something we need to add a facet to OpenLineage to capture this. So like Maciej said, we have a mechanism today to define the column level lineage. So you can say this data set has these columns and they depend from those columns in the inputs. And so you can be more precise.
Okay.
But we don't have something to say, well, this output data set depends only on that input data set. There are multiple input, multiple output, but you have more precise lineage. We don't have that yet, but that can be added. We can add a facet for capturing this.
And like this kind of situation is usually captured by different events, right? Because if you read from A to B and from C to D, those are usually different tasks.
Right, but
usually there's some join or like union or something that combines the data or separates it, right?
Yeah, I just was thinking about why wouldn't we have this method return list of lineage objects, right? So and then
we could.
Yeah, I mean, no, so I'm not trying to argue right now, but just for the sake of discussing the design, if you have Python operator and Python operator is kind of supposed to execute arbitrary code, and you can literally do transfer from one GCS bucket to another bucket, and then in the same Python operator transfer from the second bucket to the third bucket. So then how would you build this lineage? The question. How would you return this lineage?
Yeah, so for this, we would need to evolve this API to have multiple inputs and outputs. And so for operators, we actually thought about it a bit and like haven't seen a lot of usage in a while outside of Python operator. For other like systems like Spark, this is explicitly not allowed. You have like only one input in Spark every time. So yeah, it's a very valid feedback, and for Python operator, it's very useful. And
Question.
I don't know how.
Question: Can we do multiple? Like, can we emit several events from single operator execute? Because that would probably solve the problem as well.
Yes, that's one solution, right? And maybe that's the right solution.
Maybe that's it. Yeah,
that's a great discussion point. Yes,
that's it. Yeah, I think so. Today, the operator itself doesn't send events. The operator just says, "This is what I'm writing from, and this is where I'm writing to." And then the listener, the task instance listener, sends the event and saying, "Okay, so this is what the operator is saying." We can definitely go more granular. It sounds like a very specific case, but that's an extension that we can do. Yeah.
I'm curious whether you have like example of current operator, then it would like make it easy to test also, right?
It sounds like it could be a use case for a dynamic task as well. Like the task is all the same thing, but then there's a list of finds that you need to copy from one place to the other, right? So it sounds like a good dynamic task use case.
Yes.
Another example, we have this, I think, GCS to GCS operator. Isn't this just an operator that copies files from one folder to another folder? Then you probably want to have like maybe, okay, so it depends on what you want. You can have lineage on the level of each file or the lineage on the level of the folders, right?
Yes.
But yeah, okay, but then Python operator, I mean, should really be the use case for this, probably.
Any other question before we wrap up? We have 3 more minutes. Michal?
Yeah, thanks for the presentation. I wanted to ask when all these good things are going to happen. Do we have a guess at this stage when OpenLineage will materialize more broadly in Airflow?
So the first PR is almost ready, Maciej, right? Like, so I just need a big +1.
there's like wide discussion, and I think Ash Berlin-Taylor alone has created like 50 comments on it. Yeah, so this is like a gradual support, right? Right now we are trying to get the base in, and then we will like go through a list of operators and implement, you know, lineage in the operators itself, because there's a lot of them and there's a lot of code that need to be written.
Sure. Yeah. So you know, I'm sure that investing in more and more operators that's going to take plenty time and, you know, separate efforts. I'm interested in this core part that enables all of that, right?
So the core part is actually another Airflow provider. So it like does not rely on Airflow core release schedule. It's yeah. I think you want to like notice that 2.6 is very close, and but we don't require actually core changes right now. That's what we think.
Yeah. So the work is done, right? So we're in the phase where it's addressing all the comments on the PR. So hopefully it doesn't take too long, right? I'm hoping it's in a matter of weeks at this point. It's just getting a bit of back and forth.
Question
for the core, the first one.
Question which results from that, like how far back you can install the operator, the provider, and
2.6
get it working.
2.6 because we don't want to have support for bugs basically that we had in previous.
So we don't expect to the provider to be compatible with 2.4 maybe or 5.
No, we don't. And for that,
are there any
like,
technical reason not to, or is it just a precaution?
Yes, and there's like concrete PR that I could send you, which basically fix the listener API.
Okay, so there is a problem that the old API would not work with the new provider. Yes,
we would have to do ugly things in the operator.
Send it to me later. I want to like just let me know which one it is. I'll take it.
Okay.
For older version, you'll be able to use the OpenLineage integration that is in the OpenLineage project. Yeah, there's one more question from Subham. And I think we are almost at time.
So a couple of questions, like how would this work in context of dynamic task mapping? So do you have, like when Airflow has these kind of features, do you generally end up having similar kind of concept on the OpenLineage side or Maciej side in order to represent them? And second, do you support multi-tenancy for DBT today?
So for second one, we will support, right? When Airflow has multi-tenancy, right?
No,
right now
for DBT, I mean, for DBT already has the, like, I'm guessing the OpenLineage already has a DBT support. You are providing the.
But DBT Cloud or DBT?
DBT Cloud.
So we support DBT Core.
I see. Okay.
Yeah, DBT Cloud is in progress. I think at the moment it's not very different.
Yeah, there is a PR, open PR from, I don't remember who created the PR, but it's kind of dormant right now, I think.
Got it, yeah.
And what was the first question, sorry?
The dynamic task mapping kind of features, which are very Airflow specific, but how do you represent them in OpenLineage or in Maciej in general?
So like for Airflow integration, it doesn't kind of matter because we're getting called on each like particular operator instance. So for each, like if you, doesn't matter how you generate the operator, right? We will get called on its execution.
So I think it's those becomes multiple runs of that same task, right? With different parameters.
Yeah.
That's what happens. A dynamic task.
So, but you have, let's say, thousands of tasks. So do you end up creating from consumer side also, do you end up having those displayed separately as thousands of tasks? Like how would UI and everything else scale? So
I think it's all the same task. You still have a single task, but it does have many runs. It has many runs in the UI.
I see. Okay.
And I think there is a special facet, custom facet for Airflow that we have not like documented very well. that notifies you which kind of number, I think, of what's the count, total count, and like number of which tasks is it, so you can collapse it.
Got it. That makes sense.
So there's another question in the chat about how do we deprecate the existing backend architecture. I think this is a more wider question for the Airflow committers and PMC, right? I don't think that's a question that Maciej and I can answer directly because it's not up to us how this happens. So it should happen as part of this discussion. And we are really looking for feedback of what's the best way to do that. But I agree with the comments in the chat that we want to avoid having new tools.
So I think we definitely don't want to do this like very soon because you know, a lot of people have implemented it, and like removing it in 2.6 or 2.7 might be early. And I don't know what the deprecation mechanism in Airflow explicitly looks. So maybe Arek.
Yeah, my question, and I have to go because I have another meeting. But one last thing, I think, and that's again thinking, like we'll have to have a complete integration of OpenLineage and in all the operators and everything in order to think about like actually deprecating the other usage, because people have to start using it and have to have a viable way of moving out. And once the OpenLineage is in Airflow, having like partially OpenLineage in Airflow and partially as using extractors is probably not the best idea. Or I don't know how this is going to work. So we need to have a complete integration and transplant everything what we had in OpenLineage to Airflow, I think, before thinking about deprecation. And I would say the best option would be to provide some kind of automated translation, if possible, from the OpenLineage. If somebody switches off OpenLineage and uses like a deprecated backend, then they would continue using or getting the same events from Airflow. And if they have the integration implemented, they would be running still fine. That would be the best deprecation mechanism I can imagine, with deprecation warning. And generally, we won't remove it anyway until we go to 3.0, because this is our policy. So we won't remove it. We will at most erase a deprecation warning. And discussion about Airflow 3 is completely different story, which haven't even happened or haven't started at all. So I don't think we have anything to discuss right now, except like putting the deprecation warning in place. That's it.
That makes sense.
Yeah, very good details. Thank you.
Okay, thank you all. If you have other questions, like feel free to reply to that email thread. Thank you all for attending, and we'll post a link to the recording after we get it. Bye-bye.
Bye.
Bye.
Thank you very much. Bye.